Hi, everyone. Welcome to Virtual RemTech 2020 and our session today on a little bit of everything. I'd like to thank everyone for supporting this event. We have two speakers today, but before we get into that, we will share with you a short sponsorship video. Okay, well, thanks for that. Now I'd like to introduce our first speaker, who is Anila Beg from Trace Associates, and she'll be speaking today on the economic management of large area-based oil and gas reclamation programs.
Okay, I'm just gonna, can you guys see my screen?
Yes, yep, although it's in dual mode.
And can you see that screen now?
Perfect.
Okay. So I'm just gonna bear with me here. All right. So thanks everybody for joining me this afternoon. I just want to thank Isa again for putting on Virtual RemTech this year. It's been a great conference so far, a good 2 days of talks. So just a short introduction, my name's Anila Beg. I am with Trace Associates. I'm a partner and a senior environmental scientist there. And I'm also the market sector lead of our British Columbia office, which we just started in April of this year. So I am coming to you live from Kamloops, British Columbia. So I'll just get right into it. So we're talking about the management of large area-based oil and gas reclamation programs today, and just from a consultant's perspective, what that looks like. So presentation overview, we're going to talk about just the types of management we see as consultants. From a consultant perspective, how we see clients operate, stuff like that. And then just why area-based programs. What makes these area-based programs work, the challenges that we can face with them, and a few conclusions. Okay, so I'll just get into the types of management. So we typically see most environmental programs and projects being managed in one of two ways. We either see a task-based execution style or an area-based execution style. So when do we typically see each being executed? Well, we typically see task-based management when we have a smaller number of sites to be worked on. So the client usually has a smaller portfolio of sites and maybe they're not in close proximity to each other. Or else if there's multiple consultants working on one site, maybe there's one consultant that's better at remediation and one that's better at reclamation, and the client feels that, you know, we're going to get consultant A to do all the REM assessment work, and then we'll hand off the site to consultant B to finish the reclamation work. So you see that as task-based management. And then you also see it just when multiple consultants are competing for work within a single geographic area, and maybe a client is just trying to try them all out before they shrink their consultant list. You can see it in a low budget year where maybe a client just wants to hit their one or two higher liability sites and then just focus on the remediation, let's say in the fall of a big site, and that's where the money is going to be spent that year. Or else you can see it in niche work where you have one site maybe in like remote northeast BC or remote like up by Grand Prairie, but a client doesn't have any other sites up there. So it's just a one-off, but it's a big site and it takes a lot of budget. So historically, we do see lots of this task-based management. There's a lot of issues that do arise from them. Mainly that you typically don't get field staff cross-trained as much. So like I said, you have somebody doing the reclamation, you have somebody doing the remediation. So from a consulting standpoint, you have these specialized people, some in remediation, some in reclamation, but they don't really understand what the other does. So typically, that's an issue. The remediation component often doesn't take into consideration the reclamation side. So you have one person doing the remediation, and they're just getting rid of the dirty dirt and putting back clean soils. But then once the reclamation people get out there, they literally have to rework the way those soils were put back in the ground in order to make it a viable environment for, you know, the land use to come back, whether it is agricultural or treed, remote forest. And typically there's a smaller number of sites. So as a consultant, you're trying to combine work between clients to be more cost effective for that client base. So you want to do a milk run of sites. You have, let's say, four sites out near Hardisty and for 3 different clients. Well, because different clients have different site supervisor requirements, orientations, etc., sometimes it just doesn't make sense for that one person to do all 4 of those sites, just because maybe they weren't put through the 3-day training. So then you lose efficiencies that way when it's task-based like that. And then you find that you start to lose lots of momentum, and you begin to start and stop a lot of projects, which can cause a lot of rework. So what's area-based management? Well, area-based management is when a sole client has a large portfolio of sites near one another, and that you can. And when you, as a consulting company, have a small team that can kind of help you do it all. So you typically see these when, like I said, there's a large portfolio of sites in a geographical area, and when there's a specified time frame that you want to capitalize on, like a 6 to 8 week window, maybe in the winter time. You also see it when a consultant can have multidisciplinary teams. So you have your REM and your REC people, but they understand what's going on either side of the fence. You have risk assessment people who understand that, hey, like we can get phase 2 and phase 2 data back and risk away some of the pathways so that maybe instead of it going to a remediation job, it can go straight to a REC job. And then just having a dedicated team. with 1 or 2 project managers. A lot of these area-based programs are 6 to 8 weeks, maybe a month to 3 months. So you want to have consistent field staff, but you don't want that one project manager if you only have one to get burnt out. So it's nice to have the cross shift. It's nice to have 2 people on the team that can kind of pinch hit for each other. So why are area-based programs so popular these days? So before I get into this slide, I'm just gonna say a little disclaimer that I'm not talking about area-based closure as per the AER definition, where they talk about a bunch of licensees in one geographical area coming together and decommissioning well sites at the same time and abandoning well sites at the same time, and kind of leveraging one another's relationships to get an entire field decommissioned. I'm talking about just one sole client in one geographical area. So that being said, I'll get into the slide. So you typically see this when you want to get an accelerated way to reduce liability. And when there's increasing pressure from the public these days to reclaim wells. So that's why this has gained popularity over the last few years. And producers are getting increasing pressure from their leadership to reduce costs in any way they can. So this is actually a very cost-effective technique to combine costs between multiple well sites. And a number of clients are working on larger geographic clusters of wells these days. In Alberta, you see, a few clients that own the well sites all over Alberta these days. So it is also popular because there's an increasing number of wells going into the Orphan Well Association. So this is just a proactive way that the wells can get dealt with before they get to that stage of being defunct. So other benefits that we see from area-based programs are reduced road impacts and carbon emissions because you see fewer mobilizations to and from well sites. Your entire team is usually up near a cluster of sites for a given time frame, so there's less mobilizations to sites, and there's a reduction in carbon emissions that way, which really helps these days with our environment. And it also area-based programs encourage a collaboration between, your client, your contractors, the consultants. It really just is a great way to work together. Okay, so what do area-based programs typically look like? Well, they typically are cradle-to-grave programs within a defined geographical boundary, with one consultant conducting all the stages of work. So you're taking a program from a phase 1 or the abandonment when you're collecting samples after the well has been abandoned right to rec cert stage. This can typically be in the green zone or the white zone, and not usually, most of the times you have green zone and white zone depending on what area of the province you're in, and it's in the same area. So just strategically figuring out how to do both the green zone and the white zone work in that, and being cost in a logistically effective way. So this type of work consistently reduces overall costs and site execution because you literally just tackle 20 sites at the same time some years. And you're combining equipment costs between sites. You don't have to mow the hoe like 4 hours every time because your sites are 20 minutes from each other. So you can really just reduce the cost that way. And then, like I said, these programs often include commodity work. So the life cycles of these programs totally depends on the area constraints. If you're in the north, you're probably doing these programs in the winter for most of the heavy equipment side. And your constraints are probably mostly access and wildlife constraints. If you're working in the white zone, you'll probably have a lot of landowner constraints. we all know that some landowners can be a little touchy. So, maybe they don't want you to do the work that year. And you just have to adjust because you have two sites right next to each other, but you can't get into one. So then it becomes a little bit of a task-based process within your area-based program. So we can typically see these in northern Alberta and southern Alberta. In northern Alberta, the timelines are usually based on them being natural area land use and in remote locations. So you see phase ones, you usually see the phase ones getting done before the well sites are even abandoned. And those will usually come out in like April, May. And then once you want to rush and get those done and figure out what you're dealing with each of these sites. And if you do have phase twos that need to be done and figure out delineation in some of these sites, if they're super remote access, you'll probably want to start coordinating hand auger assessments via helicopters starting in the summertime, just so that you can get a good handle on what you're looking at for heavy equipment for come winter, and come up with a good plan. Maybe your phase two exceedances can be risked away, so get that into the AER before you're even building ice roads. And then typically that heavy equipment work happens when frost can set into the ground up north, and that's usually you're building ice roads in December, beginning of January, and you're doing all your heavy equipment work January to March. And that's typically kind of how a northern program goes. And then you're tree planting the following spring on all those sites that have been prepped after reclamation for tree planting. So that's typically what a program in the north looks like. What's really nice about these programs is you are very collaborative with the people that you're working with. You wanna have a great relationship with your contractors, your client, the labs, everybody on board, so that you can share resources and you can troubleshoot together. You typically have a safety. The client gets a whole safety department behind you because it's a massive undertaking. Sometimes you're following, after those phase ones in the winter, you're following abandonment around after they abandon to carry out the rest of your program. So it's very, all the stars kind of have to align, but it's organized chaos also. So you gotta be able to make decisions on your feet and kind of roll with the punches a little bit with this stuff too. Things that are easy to do in the summertime while you're making those plans after your phase twos, or even before your phase twos, are third-party agreements if you need them. If it's an area where there's lots of other different producers, you'll probably need a lot of other different third-party agreements, like crossing agreements, proximity agreements, road use agreements. If you're dealing with white zone sites, you're going to have to plan to get landowner sign off on backfill being brought in, and work out the logistics from the backfill source to your areas where you're doing, let's say, remediation, for example, and just all the kinks like that. So area-based programs are great if they're planned properly. So plan. I can't even stress enough how important it is to have a good plan going into these programs, and just a good visual plan too. Like, maps are your best friend, I find. I am a very visual person, so if I can see where the equipment is going, what the routes are, it's really easy for you to get a plan A, B, C, D, and E. Like I always say, make plan A to E, and worst case or best case scenario, you might land at C. But yeah, it's just really good to mentally prepare yourself that you're just going to have to, things aren't always going to work out the way you anticipate them to work out. And that's okay. So what makes it work? Well, teamwork makes the dream work, and great program management. It's all planned chaos. Every day will be ever changing, and program managers and the team are going to have to think on their feet. But it's just a matter of everybody on the team understanding all of the scopes, having cross-trained staff and consistent teams, and just over communicating with everybody on the team. The client, the contractors, your safety people, just everybody, having everybody in the loop all the time during those small time frame programs really helps, and it really makes people feel like they're working together. And that's what you want, especially in some of these remote locations where you're just all staying at the same hotel or all staying in the same camp. You want effective collaboration between all the parties involved. And then just, yeah, like I said, getting those upfront landowner agreements and proximity agreements, road use agreements, having upfront conversations with the regulators of what you can risk away and what you actually have to remediate, so you're not wasting money on access when you don't need to be on that site. And just being open to new ideas. There's more than one way to skin a cat, right? So yeah, just be open to new ideas, because things won't go the way you think, but then you'll find a solution that you never would have thought of, just coming together with your team. Okay, so challenges you can face with some of these programs are access issues. Like I said, like sometimes you're in very remote areas where you need to build ice roads. Sometimes when you're down south, it rains, it's monsoon season all of June, and you need to reevaluate what sites you can get into. And it's funny because even when you're in a small geographic area, it can be blizzarding on one site and it can be, just great sunshiny weather on another site. I've definitely had that when I've had two crews going, and one site is snowed out and the other site is just like love and life. So yeah, access issues for sure. And then weather. You can't control the weather. Sometimes you're working in -38. Sometimes it is super hot out and you need to mitigate heat stroke. But it's just being open and just taking those upfront safety precautions. Sometimes you get home. This is a picture on the bottom right of me and another colleague. We had just got back from a 16-hour day, went in for supper, and then the truck wouldn't start after we got out. But we were staying in a camp and we had everybody at our disposal, like mechanics, operators, safety people. So they put our truck there on a ventilator and it was good to go by the morning. But that's where that collaboration and just building those relationships with the people around you really helps. So wildlife, it's another challenge. Migratory birds, you might have a great program planned out, but you know what? There's birds nesting on a few of your sites that you can't do until those birds leave. It's just kind of how it goes. And you just end up having to have those upfront conversations with your client. Like, we can get 5 of the 7 sites done, and then maybe the other 2 need to be a different program in a different year. And then just a short time frame for the large amount of work. You just need to have the proper resources on hand. And then just the understanding within your teams that things are going to change. Maybe somebody can work a 2-week shift. Maybe somebody really needs to get out after a week, and you just have to, from a consultant's perspective, just manage the people and manage the needs of the clients and figure it out. Sometimes maybe there's a weather delay for a week, but you know what? Your people have been timed out because they've been waiting in camp. Well, you need those people on hand just to switch them out so that you can move on the work when you have that window. And frustrated landowners, just one of those challenges. Like I said, maybe you have a landowner who has 3 sites who's just like ready for you to do them all, but then you have this one guy who won't let you do his one-off site. So you can get to the 3 sites, but you can't get to that 4th site in the same area. And then just mental health. It's hard on these programs because you're go for months on end, and just check in with your team, be kind to one another. You never know how somebody's day has went or what's going on behind the scenes in their personal life. So not really, mental health isn't really a challenge. It's just something to be aware of, because maybe so and so was fine for a few weeks, but all of a sudden something's off. It's just good to check in with people, especially because you want to be a good team and you want everyone to feel safe, and it's a safe place. So yeah, definitely a great way to execute large programs and reduce liability. Lots of efficiencies in conducting these programs, but just the big thing is plan. If you fail to plan, you're going to plan to fail. When you're working 20 to 50 sites at a time, you want to have a great plan, and you want to have okay, well, I'm thinking the route's going to be this site to this site to this site to this site. Well, if all of a sudden there's birds on site 3, where's the equipment going to go? So just kind of always having that foresight in your mind of, okay, if this doesn't work, what's going to happen next? Where are things going to go? And then just dedicated and experienced program managers. Lots of clients like lots of updates. Some clients hate daily updates. So it's just a matter of finding that balance and giving your clients what they need, and then helping and managing your team effectively so that you can execute the work. And then just getting that buy-in between your clients and your team and the contractors on schedules and expectations. And then it's just an ever-changing program, so just adapting on the fly. But overall, area-based programs do increase cost effectiveness in terms of sharing equipment costs between sites, in terms of sending like lump sum samples to the lab on one courier, reduce mobilizations. Lots of ways that you reduce costs on these programs. And then just accelerator site closure for multiple sites, ultimately reduce liability. And at the end of the day, that's what a lot of operators want. So I guess I'll just open it up for questions. My contact information is there in case you want to get in touch with me outside of here, or don't feel like asking your question right here and now. So yeah, I'll hand it back over to the moderator.
Thanks for that, Anila. That was a great presentation. We probably have time for just one question. You mentioned that you're out of the Traces New BC office, but your map showed the map of Alberta. I was wondering, do you guys have experience doing area-based programs in BC, or even cross-border programs between BC and Alberta?
So we haven't done any area-based programs in BC yet, but so most of my experience has been in Alberta. So that's kind of what I was speaking to throughout the presentation there.
Okay, well, great. Well, thanks for that. We should probably move on to our next presentation. So
Thanks
again, Anila. Our next presenter is Sheila Duchek from SNC Lavalin, and she'll be talking about hydraulic conductivity assessment in prairie tills. So welcome, Sheila. The floor is yours.
Your mic is just muted, Sheila.
Yeah, there we go. Thanks, guys. Yeah, thanks for that introduction. That was really great. And thanks to ESA for having me for this RemTech, this virtual RemTech. I'm much appreciated. And yeah, so my name is Sheila Duchek, and I'm the service manager for hydrogeology at SNC Lavalin. And I have a passion for till, which is kind of something funny to admit to, but we have tills across most of the prairies. They're very typical, and hydraulic conductivity values can be challenging because they're very low to extremely low. So common methods like rising head tests sometimes can take between days to weeks, and in some cases months, to achieve adequate recovery. So I thought, well, let's look at some alternative methods to see if we can get something efficient and accurate. So my team, we looked at some alternatives to the typical rising head test, and we were looking at them specifically to characterize hydrogeology in tills. We looked at things to alter, see if we could reduce the test duration. We looked at exploring techniques to improve our ability to capture hydraulic response. Things like some of the suggestions that we thought of were altering the casing diameter. Can we use packers? Is there lab testing that we could lean on? And the goal is always to have high quality, scientifically defensible data. So the focus today will be on applied methods for determining hydraulic conductivity values within till. And preparing for this talk, I was thinking mostly about our hydrogeologists who are who are leading programs and executing these kind of programs. So in addition to the various methods, I thought I would try to include what kind of worked well and what didn't. So today we're going to talk about some prairies geology. We'll talk about groundwater flow through till. We'll talk about experimental methods and also empirical methods, and then finally putting it all together. So having that multiple lines of evidence approach to site characterization. So we could not have a talk about till without showing a picture of some ice. So as you can see, Canada was pretty much covered in ice during the maximum extent of glaciation. And how we got the tills in the prairies is from two ice sheets, the Laurentide and the Corduron. And they kind of smashed together when they retreated and advanced, or advanced and retreated. And so that kind of created how we have till sheets that blanket the bedrock. So the till that we have in Alberta and Saskatchewan can be in excess of 300 meters, and it will be, it'll consist of all the materials that were moved along when the ice moved back and forth. So you can imagine then there's a lot of mixing and smashing together. So here's a surficial geology map of Canada. And really, when you look at this, anything that's green is considered till, and some of the purples, some of the blues. So, you know, there's a lot of clays, silts, and sands on these bedrock formations. If we zoom into Alberta, you can see the picture on the right, there's a lot of green, and again, the green is till along with some of the blues and the yellows. And then when we look at drift thickness, which is the picture on the left, you can see there's quite a variety within the till thicknesses. Similarly, in Saskatchewan, the till thickness can be, you know, over 300 meters thick. And actually, I'm just going to have a quick plug for Greg Potter, who works with me. He produced an article this in May about characterizing the hydrogeology of Saskatchewan and hydraulic conductivity. So check that out in the Hydrogeology Journal. So because of all this mixing and all of these, you know, different ways that these till sheets were laid, flow through glacial deposits is actually quite complex. The till fabric might be massive, and so the water particles have to get through that, but it also can be layered in sheets with these lenses of higher permeability. It's well documented that tills have fractures within them, and the till thicknesses can be variable from a thin veneer to 100 meters thick. Then there's also weathering. So when these tills were exposed during periods of retreat, when there's no ice, the weathering was affecting each of these materials differently. So how does that fabric affect groundwater flow? Well, here are a couple of pictures. Hopefully these are familiar to most of you. But we have, you know, you might have an olive green or a gray or a brown or reddish till. You can see sands probably in there if your screen is big enough, and you can see a pebble in the one on the right. So that's just a massive blocky texture. but we also have these lenses of higher sand content, and they can be discontinuous or continuous, laterally continuous, but they represent a fairly significant flow pathway potentially that you need to assess. So hydraulic conductivity values, they're a really important parameter for site characterization, especially important for designing and implementing mitigation strategies when working with contaminated sites. So effective options of when you're looking at options for your site, they have to include looking at water flow. I mean, I'm biased because I'm a hydrogeologist, but it's a really critical piece. And so Darcy's law, which is the formula on the bottom left there, it describes fluid flow through porous media and is the basis of hydrogeology. And you can tell who the hydrogeologists are because as soon as they hear Darcy's law, their ears perk up. So next year when we're all together in the same conference room, someone yell out Darcy's law and you can tell which are the hydrogeologists. So in the spring of 2020, when I was looking at, okay, well, I would like to write an abstract for RemTech. I actually had one of my crews was out and looking at a site in Alberta, northern Alberta, and we were assessing pathways for a guideline adjustment. And one of the things that we were really key on was getting accurate hydraulic conductivity values, especially for DUA or domestic use aquifer assessment, because that's one of the pathways. So I'm not going to go over how to do a DUA exclusion, but what I wanted to show you is there's basically 5 criteria that have to be met in order to exclude the DUA, but 2 of those have to do with hydraulic conductivity. So does your aquifer have that bulk hydraulic conductivity of times 10 to the minus 6 or greater? And do you have that geologic barrier or that thick unit underneath that's at least 5 meters thick that's times 10 to the minus 7? So hydraulic conductivity values and getting accurate values are pretty important. But then what happens if there is no groundwater? Because, like I said, the site that I was working on in the springtime, the wells were dry. Or what happens when the wells are so slow, you feel like it's geologic time is passing before these things are recovering. So I looked into, okay, what kind of methods are available? And Osterban from 1994, he's produced a nice chart, which I've rearranged because I couldn't reproduce it for a slideshow. But basically there were 2 methods, and there's an experimental approach where you're using Darcy's law or models of hydrogeology, or a correlation approach where you're using empirical data that's based on observations rather than a calculated value that's derived from theory. So I'm going to work my way from the bottom up. So we're going to start with correlation methods. So in this particular slide, there's it's taken from Baer from 1972, and he's basically identified different types of media that have pretty standard K values or K ranges. And so the reason that I want to point this out is this is why it's so important when we're logging our boreholes, when you're in the field and you're looking at the lithology and the descriptions that you use, be careful if you use terms like weathered or fissile fractured, because that'll indicate, a higher flow. Similarly, when you're writing reports and you have these borehole logs in your appendices, make sure that you're looking at, okay, do these values make sense with what I've been seeing in the field? And like I said, so you could have, say, a well-sorted sand or even a fine grain sand. And depending on how that grain size shakes out, you could have different flow mechanics. And on that note, often what I'll have my hydrogeologists do is collect a grain size analysis, especially if you have a lens within your till that you're not sure if that's really a real mechanism for transport. It's a good idea to grab a grain size analysis because it might be the difference between, say, a fine grain sand or a silt. It can make a difference in terms of the hydraulic conductivity, but also it will it'll matter. So when you have a grain size analysis, it kind of allows you to evaluate your own borehole logging against something that you know is you've got some data behind it. There's also a formula that you can back out hydraulic conductivity from a grain size analyses. If you take the 10th percentile, square it, and then times it by the coefficient, the Hazen coefficient. Now, again, I don't recommend that we use that in a report where, okay, this is the K value because of the Hazen coefficient. What I'm suggesting is that we're thinking about this, and as we progress through our site assessment, that we're including different pieces of data to come up with what we think that the aquifer actually is characterized by. So here we have another source, so Freeze and Cherry, and any hydrogeologist in the crowd will have seen this type of slide before. And basically glacial till shows up on there, and it has a wide variety. So we can get anywhere from times 10 to the -5 to times 10 to the -12. And so that's why it is really important to include those K values, include those grain size analyses and your borehole logs, the lithology, to make sure that you're really understanding what is the subsurface. So now moving away from the empirical methods, we're going to look at the experimental approach. And we're going to start with the laboratory methods. So I'm fortunate in that my office in Saskatoon, the S&C partners over there, they have a materials testing laboratory. So I called those guys up because they do ex situ triaxial permeability tests. And so I asked them a little bit about, what are some of the pros and cons of using ex situ data. So, the data, it is easy to get those samples. For those of you that don't know, Shelby tubes are just hollow tubes that are pretty easy to run into the ground, and they try to capture the soil in as much of the native condition as they can. And sometimes it's good to have them because they can supplement your lines of evidence. The analysis is inexpensive, and in some cases it can support things, especially if you have limited time on site or if you have to move off site and then you have to come back to do K testing. It might help you if you have more data. Now, the challenges with the Shelby tube are the samples can be biased depending on how you do the collection, and it's very difficult to maintain that depositional environment. So how a water particle will travel through that soil sample is really hard to keep it the same from when it's in situ to ex situ, and it's very difficult to maintain anisotropy. Which is also why the results of a Shelby tube on their own are not typically accepted by the regulatory bodies in Alberta. So while they can't be used exclusively, I believe that they can supplement how your conceptual site model in your head of what the geology looks like. They can help you by supporting what your other findings are. So here I have in situ field methods get the gold star because they're everybody's favorite. They make the most sense in terms of having real data. You can get, if you work with your subcontractors, there has been an increase in innovations for tools. So things like a hydraulic profiling tool will allow you to get hydraulic conductivity measurements in a vertical profile in one borehole. And you can also get electrical conductivity values with that. There's also the direct push permeameter, which works kind of in the same way. It injects water and then measures pressure changes. Or the cone penetration test, which is a sensor on the top of a tip, and it measures the pore water pressure measurements as you're moving down. One thing that I would like to try, we've done quite a few packer tests in bedrock and unconsolidated soils, but I haven't personally worked in where we have packer testing of some really stiff clays. So the way a packer test works is you would put some packers down, 2 packers, you inflate them using the airline, And then you inject water at different pressures, and the pressure sensor measures the changes. And you inject the pressures that you apply. You pick your maximum pressure, and then you kind of build up to the maximum pressure, and then you release the pressure on the way down. And that allows you to evaluate how the formation responds in response to those pressure changes. So more to come on that one. So other in situ methods, and these are more based on you actually have a monitoring well in place and you can monitor the water levels, or if the well is dry, and then we basically have below groundwater, means they're the standard tests that most people are familiar with, and above ground is for when you're in the soils above where water is saturated. So in a typical rising head test, I'm not going to review that because most people understand you bail it down and you monitor recovery. And the output is pretty standard. It looks something, this is one that I was just working on. And so I'm not going to spend a lot of time on that. Same thing with like a constant rate test. So I've done constant rate aquifer tests on an unconfined aquifer. And there's lots of great courses out there in order to how to assess a constant rate test. For this particular one, we were looking at the deliverability, and it turns out that our K value, we backed that out from the transmissivity. But typically until it doesn't produce enough water that you could actually do a reliable pumping test. So we're pretty limited in the application for that. So then I thought, okay, well, what if we were to change the diameter of the well casing? What if instead of having, a larger, like the 2-inch, what if we made skinny little wells when we were looking at those geologic barrier wells? Would that help us? Would that reduce the time that's required? So I had to pull out the textbooks. I pulled out, found Darcy's Law, and did some moving the equation around to figure out to solve for K. And basically, I've isolated K, so it's a change in volume over a change in time. And when you back that out even further, so that it's not just the change in the volume, it's actually the change in your radius. So the radius of your casing and the radius of your borehole, you actually see that the changing the radius it creates a fairly minor change. So even if you do change the radius of the borehole and the well casing, it's exponentially related to the change in time. And so it doesn't really help you in terms of reducing the amount of time. So I thought, well, okay, what if we just do less displacement, which is kind of the same thing as reducing the volume. But the implications of having lower displacement means that you're going to start running into issues with the precision of your instrumentation. So if your water level tape is only accurate to say the millimeter, and the accuracy of pressure transducers and sensors, they vary. If you reduce the amount of displacement, then it makes the recovery that much more difficult to monitor. And then we have to consider the well construction details. So most water table wells, or the most shallowest ones that are completed inside of till, they're 3-meter screens. So we have to consider that the K-test design, or the design of the K-test analysis, it has to be done in consideration with the well completion design. So the other thing is, don't get hasty and cut your test too short, because you could lose important information. And I recognize that, and I wanted to highlight that because I do think it is pretty important. I also found a quote from Sterrett from 2007, and he says, if an aquifer test does not continue long enough, the resulting test may not indicate the true nature of the zone of interest. So I thought that was well said. I also, when we do a hydraulic conductivity test analysis, typically we look at things in normalized head. So when I started, looking at the displacement and changing the displacement from displacement to normalized head, I realized like that does depend on the well, and it depends on the formation and things like that, but it didn't really buy any benefit. So that was kind of a dead end as well. So what about dry wells, right? So like I said, the site that I was working on, we had some great geologic barriers. but the wells were dry. So how do we determine a K value if we have dry wells? So based on the literature, there's a couple of methods. They have basically these rings, and then you fill the rings with water and monitor how the water not evaporates, but dissipates through time. But the problem with these is they're too shallow. They're very limited to the uppermost part of the soils. And so that doesn't really help with, our water table wells that might be 6-7 meters deep. Same thing, there's a Guelph permeameter. So, we looked into a commercially available unit. Well, maybe we could get a K value out of that. But really the maximum depth for that one was 80 centimeters. So that didn't help either. So we elected to do a falling head test on a dry well. And so what we did, we just calculated how much water we needed for injection. We confirmed the well was dry, installed our transducers, and then injected clean water. So by injecting, I mean poured in clean water. And by clean, I mean we bought deionized water from the grocery store, some jugs. And I thought I should mention that when we are talking about clean, clean in this case, we tried to pick wells that were not going to be used for sampling groundwater chemistry samples, because if you have to go back later, how do you know that the water that you've injected isn't impacting the chemistry? So just a note of clean is in quotation. But basically, because these wells were dry anyway, there was no risk of that from my perspective. So you inject the water and you let that water dissipate. And then at the end of test, you'll have a little bit of water at the bottom of the well. So it's important to note here that the basis of hydraulic conductivity testing models is based on, like, one of the assumptions is that the formation is saturated. And so when you're thinking about, okay, how am I going to do the analysis for this, you have to remember the saturation bulb. So as you inject water into the formation, you have to make sure that there's a saturation bulb that's been established. And when we did our test, you can see we have kind of two slopes to this curve, but that one slope is the saturation bulb. So it took an hour or two for the saturation bulb to hit the maximum. And then we monitored it over time, and the output looked really great. Like, I mean, I don't think it gets any better than that. And our hydraulic conductivity value was then 1.3 times 10 to the minus 8, which met the requirement of a geologic barrier. So now that I've kind of talked about all the methods, I wanted to talk about multiple lines of evidence. It's an approach that a lot of regulatory jurisdictions use or they apply in site assessment and characterization. And what is it? Well, it's using data from independent sources. So maybe field data, maybe laboratory data, to determine specific characteristics of a site. So the data might be complementary, it might not be, but it will support the overall understanding of your site, because if there's things that don't make sense, then it's a data gap you need to evaluate. But really, its key is to understanding your site's physical, chemical, and environmental characteristics. And even for a routine site where you might be able to do hydraulic conductivity tests, you'd want to do at least 4 if you can, because you can use the geomean then. But also, you want them spread geographically across your site so that you have a better representation of what that aquifer's response is. So 4 tests are definitely better than 1 perfect test, because the 1 perfect test is only going to represent near borehole conditions. So in summary, we discussed the origin of tills in the prairies. I talked a little bit about groundwater flow and the importance of hydraulic conductivity values. I reviewed methods of determining hydraulic conductivities, including in situ and ex situ. And we discussed multiple lines of evidence, which I'm hoping everyone looks to adopt and looks at more than just one testing method for being presented. And with that, I would like to say thanks to everyone for hanging on to the very bitter end with me, and that wraps up my show.
Thanks, Sheila. for that great presentation. Extremely informative. If anyone has any questions, please send them in. We just have a few minutes left, or we could ask Sheila a few questions. I just had one question, Sheila.
Sure.
As you know, like some sites or for some investigations, you have to send data, through a regulator for their approval. And this may be a better question for a regulator, but I'm wondering what sort of success you've had with some of the more esoteric methods for determining K values, like besides the hydraulic, the typical type of slug tests, if you've had success with any of the correlation data or any of the other methods you mentioned.
Yeah, so what my approach has been is when I have that data for grain size analyses, typically, or even like you said, like not necessarily correlation data, like I don't necessarily recommend sending that in, but does it line up? Have you assessed different ways? And honestly, what I have done is submitted grain size analyses for sand lenses. I've submitted Shelby tubes because we had the data anyway. And although, if I was the regulator, I would understand that, okay, yes, we want to see the in situ hydraulic conductivity response from like a rising head or falling head test. But as a regulator, if I was a regulator, I would appreciate, okay, yes, we have gone beyond that and there's more data to support it. And that will give the regulator, I believe, confidence that you're assessing your site appropriately and that, you have, more than just one method of determining what that K value should be. It gives you more confidence is what I would say.
Okay. Well, great. Well, thank you, Sheila. So there hasn't been any other questions. So I guess with that, we will end this particular session. Again, I'd like to thank both of the speakers, and I'd like to thank RemTech itself. If everyone wants to check out Brian Keating, I believe he's coming on after the break. So have a great day and take care.
Thank you.